Hey Technostuds, there are a lot of hackers out there. And there's also a lot of programs that facilitate hackers when they're trying to break into a network and when they're trying to break into a machine. In fact, you don't really need to be all that technical nowadays to run some program to learn how to hack into a system. There are just tools out there that are readily accessible to do exactly that. In fact, if you take any public IP address, it's probably getting scanned multiple times every single minute looking for vulnerabilities. So much so that if I were to take a machine that has not been hardened yet and I put a public IP address on it and I put it out on the internet, it will probably get hacked right away, provided that you haven't hardened it yet. So what we need to do is we need to go through the process of guarding against that. We need to put safeguards into place, multiple safeguards to protect our equipment, to protect our network, to protect our end users. And so what we want to do is we want to practice security in depth, where we make sure that everywhere along the way we put up safeguards that protects our resources from the outside world. In this video, let's first of all go over what those endpoints are, and then we're going to get into some host-based protections, things that are going to protect those endpoints. And then we'll talk about several different network-based protections, things that we can implement on our network to protect our hosts. Some of them are going to be related specifically to Cisco or Cisco devices or Cisco services, while others that we're going to talk about are just more general things that you would find with other vendors as well. So let's go over endpoints and how we're going to protect those endpoints. So what are endpoints? Endpoints are the devices that you'd find at the extent of your network, at the end of your network, not in the middle of your network. So an example of this would be like a camera or a computer or a server, a printer, a laptop, all your devices. Here's a copier, here's a tablet, a VoIP phone system, another type of camera. So these are all endpoints. These are the points in which we're providing services for. We're providing the network services for. And these endpoints, they go by many different names, hosts or endpoints or end devices. But the idea behind this is that many of those are more prone to being attacked. And that's for a few reasons. Number one is they're just more prevalent. You have a lot more computers and laptops and phones out there than the actual networking devices that support those computers, laptops, and phones. So just by sheer numbers, somebody is going to want to attack those more so just because they can do more damage. They can influence a wider number of objects. So people write a lot of malicious code more towards these devices because there's more of them. But that's not the only reason. There's a lot of these devices, there's users that are getting onto these different devices, especially something like a laptop or a desktop, where there are end users that are using these devices that are not real educated on keeping things secure and making sure that they are doing things in a secure manner. They are accessing things like web browsers that go and browse the web, which there are a lot of different malware and problems out there when you're browsing the web. And same thing with email. You're accessing these devices and things are getting downloaded onto your machine. Mail is getting downloaded onto the machine. So they're a lot more susceptible to these malwares and to different viruses and different malicious attacks that are out there. So one thing that we want to implement is a host-based protection. So on these devices, we want to make sure that we have hardened these devices, that we are securing these devices. We want to make sure it has some sort of antivirus and anti-malware on there that's protecting the machine from malicious code of accessing that device. We also want to implement host-based firewalls. These are the firewalls and the firewall settings that you find on the actual machines. So we want to put a firewall up on this machine, but we also have then a network firewall, which we'll get to here in a second. So this is that security in depth. We want to make sure that we're protecting this from multiple layers, and you'll create a host-based firewall as well as a network-based firewall. You have the host-based intrusion prevention system. So a host-based intrusion prevention system is something that's on the host that's detecting if something's trying to actively hack it. And then what it will do is it will prevent that hacker from being able to get into it and being able to access certain things on there. So, and it's the key to this is host-based. We'll talk about intrusion protection, prevention system and intrusion detection system here in a second, again, from a network standpoint, but we know that we also want this on the host level as well. And then things like VPN can help also secure our traffic that's coming to and going from our different devices as well. So this is host-based protection, and we want to make sure that we have host-based protection on our devices on our network. And one call out here as well is just because we're talking about the host base, we also need to, our networking equipment, make sure we protect those as well. So this doesn't do away with doing some of this on the networking equipment as well. There are people that are going to be trying to hack those things as well. It's just that these end devices are a little more susceptible to these attacks. So there are also a whole bunch of network protections, things that we can incorporate before any malicious code or any malicious people get onto our network to stop them before they even access our network. And so we have things like firewalls, that we would implement a firewall at the front of our network to protect it from the outside world. And maybe on that firewall we use access control lists, or maybe we don't have a firewall, we just have a router and we need to implement some access control lists on that router. Or perhaps we have a layer 3 switch and we need access control lists to block certain traffic between our VLANs. So we will definitely get more into that. And then there are also a whole host of other types of services and appliances. Appliances would be like hardware or virtual hardware that actually protect our network. And a service would be something that runs on that hardware, or that a service that runs on a server to protect and help us give insight into our network. So we're going to talk about quite a few of these different options here. So one of those is this Cisco Secure Endpoint. And now notice that it does say endpoint on this. However, this is something that we could get actually on one of our firewalls, one of the Cisco ASAs. And it went by a different name in the past. So you may see sometimes it's Advanced Malware Protection, or AMP, but it's been rebranded as Cisco Secure Endpoint. Now the key to this is it's malware protection. So this is going to protect your end devices, but it's going to be running from a network level standpoint. So this is one of the things that we can purchase and run on our network. Now, because of the tests lag a little bit what the industry has out there, you may see it on the test as Advanced Malware Protection, or you may see it as a Cisco Secure Endpoint. But the goal of this, or essentially what it is it's going to stop malware and other threats from ever getting to your end devices and stopping them at the doorway to your network. Another thing that you could configure on your network is this real-time monitoring tool, or RTMT. The real-time monitoring tool is installed as an application on your end devices and goes along with the Cisco Unified Presence. So what this is for things like instant messaging and other Cisco communication tools. And so this will actively manage the real time, will monitor to make sure things are protected on your end devices. Then we have Cisco Secure Network Analytics. This also went by an older name of Stealth Watch. So if you see Stealth Watch, you can also think of Cisco Secure Network Analytics. And so Cisco Secure Network Analytics is really think of a dashboard. So you have these other things that are running on your network and it reports up to this dashboard. So you have a single pane of glass to look into your network and how it's performing. So that's where this Cisco Secure Network Analytics comes in. Then we have the Cisco Secure Email. Cisco Secure Email was formerly called Email Security Appliance or ESA. So if you see something about ESA on the exam or you see something about ESA in text, that is talking about this Cisco Secure Email. And it's just a way to filter out email, making sure that there's nothing malicious, no malicious code on email as it enters into your network. Similarly, we have this Cisco Secure Web Appliance that filters for websites and making sure that there's no malicious code on websites. This Cisco Secure Web Application was known before as Web Security Appliance or WSA. So this is going to sit on the edge of your network and just confirm that you're not getting any security issues from websites that your users are visiting. We did mention the host-based intrusion detection system or host-based intrusion prevention system. Let's talk about what an intrusion detection or prevention system is, or we call it an IDS/IPS. A intrusion detection system is going to detect if there's anything that's coming into your network that shouldn't be coming into your network. So what that looks like is you've got some sort of end device, and as traffic enters into your network, it's going to take a look at that traffic and look for suspicious traffic. And then once it detects suspicious traffic, then it will notify you. So that's an intrusion detection system. But the intrusion prevention system will actually do something about it. So whereas a detection system will just detect to see if there's some sort of something trying to hack your network, an intrusion prevention system will then actively start blocking it. Now, one reason why you would go with a detection system and not a prevention system is because a detection system is not going to actively cut traffic off, which could be a problem on your network. Maybe it's legitimate traffic and it starts cutting it off. That could be problematic. And so you want to be cautious when you actually roll out an intrusion prevention system. However, the nice thing about an intrusion prevention system is it will cut off that traffic when it sees something going off, something that is wrong about the traffic, then it will cut that off and stop the attack from happening. If you've watched all my videos up until now, you may have seen me already talk about a AAA server or AAA service. What we can do is on all of our devices, we can authenticate locally. We have a username and password that you log onto that device, and it's just a local username and password assigned to that device. But we can also set it up to talk to a AAA server. And that AAA server is going to do three things. First of all, what it's going to do is it's going to authenticate. It's going to make sure the person is who they say they are. Okay, so think usernames and passwords or multi-factor authentication. We do some sort of authentication to make sure that somebody is who they say they are. And then the next thing it does is authorize. The idea behind authorize is it's giving them access to specific resources. It's not enough to identify the person and who they are, but also what do they have access to. So if somebody tries to log on to this device right here, it may go and authenticate them and then say, yes, this is this person's identity. But the second question is are they authorized to be on this device? Can they be on this device? Do I allow them to get onto that device? And then finally, the last A of this is going to be audit. And the audit part of this is where you have some sort of log. That this information then gets logged on the AAA server, so you can go back and make sure that things are all on the up and up, that nothing looks out of the ordinary. And so it's going to create an audit log of what has happened. And in this case, it says this person has accessed this resource right here at this particular time. So what is, where are we going with this? Well, this is going to be just a service that is going to be available in a lot of different vendors, but one of the vendors, Cisco, what Cisco offers is this ISE, and the ISE is the Cisco Identity Service Engine. So the Cisco Identity Service Engine, or ISE, provides those AAA services, the authenticate, authorize, and audit. So, and the key to it is it's identity services. It's also shortened to ISE. So that could be something that you see as well. ISE, think about authenticate, authorize, and audit. Network access control is not specific to Cisco. There are a lot of different vendors that do this network access control and a lot of different protocols that can help with this as well. But essentially what it is a series of checks that before you allow a device or a user onto a network, it does some sort of authentication, it does some sort of authorization. So we have the AAA. It also maybe takes a look at the machine to make sure that the machine is up to date. So there are several different policies and things checks that it can do before you are able to access the network. But the key to this is some sort of checks and balances to make sure that you are in the right mode, you are the right user, you have the right parameters to access the network. So in this video, we talked about what an endpoint is and the need to protect those endpoints. And the way we protect those endpoints is, number one, is we install host-based protection, things that are going to reside or is going to be on that individual host machine, protecting it to making sure that it's not getting attacked. But there are also going to be network-based protections, things that sit on the outside of the network and things that sit on the inside of the network to protect those end hosts from things ever actually getting to the end host. So that is all about endpoint protection.